Hello, what's up fam, how you doing? In this video I want to show you how to control a servo motor via EGF Arduino Plus well connected to a joystick module. And even you can turn all over, and when I press the button it scans perfectly. So let me teach you at first the logic, then step by step how to code it, and finally testify the project. Let's do it. To begin with, a joystick module is a kind of double potentiometer with a built-in pull-up resistor, push button, and the output when it is in the middle is 512 steps or 2.5 volt. Here's the X and Y axis well connected to ground, and here is our push button key, and we can send 0 or 1 signal to digital pin of Arduino. And now we need to calculate a slope line equation. So in this way, when we rotate the joystick, the servo motor can rotate mutually. For example, when we are in the most right position, this potentiometer, or maybe the joystick right or left position, is 1023. So the speed of servo is 180. And when it is in the middle, there is no action, it is solid 0. So in this way, we can calculate M equals to Y2 minus Y1, X2 minus X1. What the result will be is kind of 0 minus 180, 1023 minus 512, and the result will be minus 180 divided by 512. And if your joystick has a fault tolerance, you can add to your equation. So this is our M, or slope line equation. Now it's time to write Y minus Y1 equals to M times X minus X1. Here is 0, this one is minus 180 minus equals to minus 180 degree on 512 times our, this X is our value, minus 0. With divide and conquer, we can solve this equation. Y equals to minus 180, we divide all on 180, so we have 180 512, and it moves up and will be positive, so this is our value, or X, plus 180. And even you can add your fault value here if you have a faulty. And in this way, we can code our project and rotate our servo. Let's go for coding the project and then testify step by step. Now it's time to code our servo project. So in this way, we should add a library and choose a name for it, as you can see here. Then we should add a define code to define our trigger and echo pin. Kinda trigger is a transmitter and echo pin is a receiver. When the ultrasonic sound is sent and it is reflected, echo pin should stay high enough to get that data, and with long duration and distance we can calculate. So in this way, we need a button, a go button with the digital data to the digital pins. Kinda button assigned to 11th pin of EGF2 Another one is joystick Y pin assigned to A1. Reading analog data is needed here. Then for rotating the servo, we need the float value. When we did that right, it's time to define as our serial begin channel. So here is 9600 T's, and it should be equal to our baud rate here, for example, is on 9600 T's too. Another one is that my servo attach pin is the 9th pin of Arduino, and modification of button value is a kind of input pull-up resistor well connected to GND. So in this way we can send the data as I said. And this way at first the value is 1. When we push that button it will be 0 and we can send the trigger. So here the trigger pin is output and echo pin is input. In the while loop we should read that data, analog read and digital read. As I said, when a Y value is less than 608. And now it's time to calculate and rotate our servo motor. So in this way, if clause here Y value under 608. 608 is my faulty tolerance of my joystick module. For example, my module is not exactly 512 steps, so I defined it as a 608. The value in this calculation we have minus 180 divided by 512 times Y value plus 180, and we can write on a mic servo with that value. When we read the serial input, we can choose between a B value. If it is 0, I mean exactly 0, it should be triggered. I mean all ultrasonic sensors. In this way we should for example delay them in microseconds. At first 2 microseconds, then 10 microseconds is a kind of usually act, so the echo pin can get the data and we can calculate the duration in centimeter. But you can change it without any problem. As you experiment more, you get more value. And if you wanna get an exact input, not more unexpected value, for example, when you push the button, for example like this, you don't want to get more values like a null line with 0. So in this way you should add if distance greater than 0, and you can print the distance here. And here you are. Now it's time to testify our project, so let's go for it. Now all things are well connected. As you can see, for example, here X pin and Y pin is connected to analog pins here. Then the SW is well connected to the digital pin. Here's a VCC, and GND here, the ground, were connected to the power supplier. And then is our servo motor. A trigger pin is connected to a PWM pin, a digital pin, and power is connected to the power supplier too. And now when I rotate, you can see, and push the button, it works properly. Please thumbs up the video and subscribe for more. Bye bye.